Okay, one more math topic, and this is calculus. So, you start with the three R's, you reading, writing, arithmetic, and sort of arithmetic makes kind of sense. However, as you uh, progress uh, and you get to like late middle school or high school, and suddenly you're hit with this calculus. Now, arithmetic operations like addition, subtraction, multiplication, division make sense. You can relate them to the real world. For example, if you want to calculate how much food you want to get for your guests, you'll use multiplication. Or how many trips will you need to move a certain quantity of rock, you'll need division. So intuitively, you have an idea about multiplication and division. And of course, addition and subtraction. That's also pretty intuitive. Then you come to calculus, and suddenly you are like, all these strange notations and what's going on? What's the intuition? What is the intuition for calculus? That's why you come to me. I give you the intuition. So, I have a video which kind of gets into the subject in much more detail. It's on my YouTube channel. It is called Calculus is Easy. And it is easy, fun, and interesting if you can relate it to the real world. The intuition for calculus is that integration is really multiplication, but it is multiplication of quantities that change. What does it mean to, how can you multiply this quantity and this quantity, but this quantity is non-constant and this quantity is non-constant. So what does it mean to say that you can multiply these two quantities? Watch the video. Okay, and the example of things where change quantities is, for example, the distance traveled is velocity into time, and the velocity is not constant, then you can still calculate the distance traveled by integrating the velocity with respect to time, which is actually taking little bits of velocities at points in time and then multiplying it by the range of time and so on. And so that is integration. It's really multiplication. Similarly, differentiation is really division, even though you're told in class that dy by dx is not a ratio of dy and dx. It is just a notation, which is correct. I mean, if you are following the axioms and you're doing it rigorously. But as an engineer, I just kind of give you the intuition. So the intuition is that differentiation is really you can say instantaneous division, like just small changes in one quantity divided by the small change in the corresponding small change in another quantity. And why would you want to do that? Well, there are many physical relationships in the world in which that ratio of the small change in one quantity to the small change in another quantity is important. For example, acceleration. Instantaneous acceleration is the instantaneous change in velocity divided by the period of time over which it has changed. Now, of course, instantaneous means that the period of time is very small. So you have these two. Integration is multiplication of quantities that change. Division is differentiation is division of quantities that change. And of course, what do you have when you have multiplication and division? They are the reverse operations of each other, right? And then you get to the fundamental theory of calculus that integration and differentiation are the reverse operations.